Here's a quick demo of the piano effect in its current form. You can either, I'll walk through the steps. First we're going to, I'll just open an existing sequence, or you can create a new one if you want to follow along and just hit pause occasionally. For this one I'm using a 32 by 32 vertical matrix. 32 by 32 worked pretty well for the graphics on the example files that I provided, but of course, you know, you can change it however you want. Okay, so let's see. What we want to do is select the piano effect. Oops. And first we'll start with the top view of the piano keys. For the number of keys, I need to add a little box here, and for the number of rows to show the actual number. It's too hard to position it by just the slider itself. I guess we'll just kind of leave it as that default value for now. Placement is not currently used. Okay, so then the next step would be to select the cues file, and that's basically the Audacity onsets. So I have a file here. So this is going to define which notes are on and off at any particular time during the sequence. Okay, the next step is to map. Actually, I should probably go in a different order here. Let's start with the shapes. Okay, so the first, I guess the first real step would be to select or define the shapes. And I've created some example files here. The one called Piano Example Key Top Shapes shows the top view of the piano keys. If we just want to take a look at that real briefly here, it's a single image, but it really, let me zoom in. Oops, let me scroll it into view here. Okay, there we go. Okay, I'm going to zoom in because it's only a 12 pixel by 6 pixel image, and it consists of multiple sub images within it. I probably could have made them separate pages, but instead I kind of used the game sprite technique where you tile all of the images in, or sub images, into one bigger image, and then that way it only has to load one file instead of multiple. So the example key top shapes, it consists of multiple sub images, 3 by 3 pixels. Okay, if we look at the first one here, this 3 by 3 pixels shows a white key with a black key to the right of it. If you just look at those 3 pixels there. Then if you move over a little bit, the next 3 by 3 sub image shows a white key, which is represented by the green, with a black key on either side of it, which is represented by the blank areas, which are transparent in this PNG. Then if you move over 3 more pixels, then it's a white key on the right with a black key on the left. So those are the only 3 combinations of black and white keys that are visible on a standard keyboard. Then if we move over again, the next 3 by 3 pixels is just the black key itself. So that's going to just be 2 by 2 pixels. So that'll fill in where these blank areas are here. That's the upper half of the example keyboard images. The lower half is the same shapes but different color or different shade. So I'm using the top half for the on keys or the pressed keys, and the bottom for the off keys or in their up or unpressed state. So in other words, when a key is turned on and off, it'll flip between the first color and the second color. When this file is loaded into the piano effect, it scans the pixels starting at the bottom left and produces a list of colors that it sees. So in this particular example file there are 4 colors plus the transparency, and those 4 colors will be mapped to your current palette selection. So then if we look back in xLights, we have 4 colors. Normally, well, I guess the default palette is the red, green, blue, and yellow. You can leave them like that, but if, for example, you wanted the same colors to show in xLights that are in that example bitmap, then you'd need to change it to be dark red, dark green, light red, and light green, which I did just a moment ago. That's why it was already set this way. So this would preserve the colors, but of course you can change them also. You know, that's entirely up to how you want the keyboard to be displayed. Okay, so we have the shapes defined and their colors. Then in the middle tab, the Q to shape map. What this is going to do is describe the names of the notes and where and how they will be displayed on the target rectangle. So I provided a sample file for that, also called what was it called? Piano 88 key shape map text. If we want to look at that, it's just a text file. Okay. And it's got multiple columns in it. The first column is the name of the note. In this case, it's the MIDI note number, but it's really just a text string. So, for example, note 21 is in the first line. The next 2 columns define the X and Y coordinate of where that shape starts in the shapes file. So, for example, this would mean X and Y location of 3 and 3. The origin is the bottom left. So this would display, well, and then the, 3, 3. Okay, so if we go to the actual shapes file again and zoom in, okay, so that would be referring to, well, here's 3, 3 here, so it would be referring to this portion of the shapes file. And that's the on shape, or the pressed state. The unpressed state, or the off state, has another set of coordinates, in this case 3, 0. So if we look back at that, that would be the, 3, 0 would be the lower portion. So that would be these 3 pixels instead of these. If I got that right, I said, what did I say a moment ago? Sorry, let me, look back here. 3, 3 is the on state, and 3, 0 is the off state. 3, 3, okay, sorry, we're talking about these 3 by 3 pixels for the pressed, or the on state, and 3, 0, these 3 pixels for the off state. I could have put these shapes in separate pages within a multi-page file, but I was kind of thinking in terms of sprites or, you know, the game stuff, so I just put them all together, tiled them together into one image. Okay, so getting back to the shape mapping file. And then there's the width and height, which is just the number of pixels to pull out of that shapes file. And then moving on over, there's the destination X and Y. That's going to be the location in the target rectangle where to draw those. And so the first note is going to go at 0, 0, which would be the very left end of the keyboard. If we go all the way down to the bottom, the 88th key is going to be at 153.0, which is at the far right of the piano keyboard. So in other words, this defines the key shapes for the entire 88 key piano keyboard. And okay, so going back up, so then I also have a destination Z column, which I intended to use for layering, but it's not currently used. Like I was originally thinking that the black and white keys overlapped, but then I switched over to just using transparency to account for that. So you can ignore the destination Z column. And then after that there's just a comment. The pound sign means it's a comment, so it's ignored, but this is the note name and frequency, and then the actual, I have a letter shape here at the end for the white keys just to remind me what they look like, with an I meaning the white key is in the middle with a black key on either side, a J means the white key is on the right, black keys on the left, and the L means the white key is on the left with the black key on the right. If you look at the shape of the letters, that's how I used. That was just kind of a reminder how these things look, but in actual practice you don't really need that information. Okay, so that's how the MIDI notes are mapped onto shapes. Okay, and then we also load the cues file, which is the Audacity onsets or other information. I have to remember to update grid, which I keep forgetting to do. And then if we go ahead and play this, let me scroll it into view here. Okay, you'll see the piano, keyboard, and you'll see the keys highlight as the various onsets, or I'm calling them cues, occur within the file. So this is just Ghostbusters here. I hope you can hear it okay. Seems like it might not be getting all the notes, but it seems to get most of them, so that's probably good enough for now. So that's, let me stop that. So that's how the piano effect looks. So my example 3x3 shapes are being stretched. The width is actually staying the same. 3 seems like a good width to leave it at, and the height is being stretched to the total height of the target rectangle in this case. So those little sprites or shapes can be stretched as needed to fill the available space. What else do I need to say about this? Okay, so that was the basic top view of the piano keyboard. Let's briefly do I guess the scrolling piano. In this case the shapes don't really make sense to have the same shaped keyboard, the same shaped keys. So I have another file here for the key edges called piano example key edge shapes, and that was intended to represent the edges of the keys. Okay, so we have piano scroll selected, so let's run that one and see how it looks. It probably needs a little bit more tuning. Oops, there's a little bit of a redraw problem at the top there. I thought I fixed that. But that's how it looks. Obviously the piano keys are a little bit strange in this. I mean, they have to be drawn differently because they can't overlap, but that's kind of how that looks. And let's see what else. Okay, so that was the player piano. Oh yeah, equalizer bars are similar. Very similar. I mean, it uses all the same mechanism. Basically the only thing that's different is the scroll direction. So let me show you that one. So for the equalizer bars, I just draw the entire height, and then it gradually decays. At this point in time, I'm not looking at the volume. That's going to require some additional logic in there. So what I'm doing is I'm just picking a random height between 1/3 and 2/3 of the height of the target rectangle, and it draws it then, and then it draws it at that height, and then it scrolls it down gradually. But it does kind of give the general effect of an equalizer. So I think that's the equalizer's okay for a first try. Oh, there's one thing I forgot to mention down here on the beside the shapes. There's a clip checkbox. What that does is if you only want to see part of the keyboard or a specific range of keys, you would turn that on, and it will cut off any keys that don't fit within the rectangular area. If you turn it off, the keys wrap around, and they wrap around at an octave boundary. So for example, in this demo I used a rectangle that was 32 by 32, and the keys themselves were 3 pixels wide, so if 10 keys would fit on this particular display. So if like A3 and then A4 and A5 were to be played with the clip turned off, those will all end up in the same location because the keys wrap on an octave boundary. That way you can show a smaller number of keys and still get the piano effect. But if you don't want that, you can turn on clipping, and then it will just show just the left portion